Okay, let's do some fractions. So they tell us to use the reciprocal method for fractions. Same like multiplying, only what we're going to do is flip this fraction over. So 5 divided by 1/2, we're going to flip this over. 5 times 2 equals 10 over 1 equals 10. If we think of this in terms of a decimal, 0.5, the question is somewhere right here, or like it's written here, how many times does 0.5 go into 5? And the answer is 10. So why do we use the reciprocal is sort of the question. If we come back to 5, if we work our way backwards here, 10 times 1/2 equals 10 over 1 times 1 over 2 equals 10 divided by 2 equals 5. So if we elaborate on this a little bit here, 10 over 1 divided by 2 over 1, I'll just take a little sidestep here. When we get into canceling and we deal with multiplication division, say 6 divided by 3 equals 2. So say I wanted to get 6 by itself, I would multiply by 3, cross that out, 6 equals, move the 3. If we multiply by 3, we multiply by 3. So 6 equals 2 times 3. So 2 times 3 equals 6, a little redundant there. But either way, if we just take this method and we apply it right here, and we break this open, 10 over 1 divided by 2 over 1. Now we want to get rid of this. We want to get 10 over 1 by itself. So times 2 over 1 equals 5 times 2 over 1 equals 5 over 1 times 2 over 1 equals 10 over 1. So right here is where it's reciprocated, but sort of just a little bit of a method to get us through the whole, just a little bit of an explanation on how we get to that point. So decimals. Now, so we're going to move ahead to dividing decimals, or creating decimals. So I just want to, we have a base 10 system that's been created, and decimals are part of that system. So we have the thousands, hundreds, tens, units, 1/10, 1,000, 1,000, 1/10,000. So basically this unit, if we think of it in terms of an odometer or something like that, this unit will multiply 10,000 times before 1 is expressed. So if we have 1 kilometer, 100 kilometers, 10 kilometers, or 100 meters, 10 meters, 1 meter, and this is expressed as 1 kilometer, this would multiply over and over and over again until we got to 1 kilometer. And this, whatever number is on the left of the decimal, this number represents the accuracy of the measurement. Now, these aren't set rules. This is just a conversation that I'm having. So if we say 2 divided by 1, the 2 doesn't go into, 1 divided by 2. The 2 doesn't go into 1. Perhaps the statement is that there is no 1-to-1 ratio present. Again, this is just a conversation I'm having. So the question, is there a 1-to-1 ratio here? If the answer is no, then sort of how many times do we go through the process? So if the answer is no, there's 0. So the thing for me is we move the decimal over here, but say 2. 2 also has a decimal. Why are we moving one decimal and not moving the other decimal? So we have, sorry, I had an interruption there. We're not moving one decimal. We're moving this one, but not this one, if we express it in these terms. So why are we not moving both decimals? So if we think of it in these terms here, again, this is just a conversation. If we line everything up, we have sort of the same value here. We have a unit and a unit. Is there a 1-to-1? No. So it tells us to move the decimal over. Now, this is taking off infinitely. And if we move the unit over as well, now we're going to move this place over with this decimal, and we have 5. Again, this is just a thought experiment. So if we take the same sort of idea here, and we deal with 1/8, do we have a 1-to-1 ratio? No. And we're told, okay, so we'll move the decimal over, it goes into 10, 8, got 2 left over, drop to 0. We got 20, it goes into 20, 2 times. 16, 4 left over, move the decimal, drop to 0. We have 40, it goes into 40, 5 times, we're left with nothing, and that's where we stop. So that's how we create the decimal. So just to show a little bit on the previous page there. So here's your units, here's your tenths. So again, the accuracy of the measurement is sitting within the tenths, within the hundreds, and so on and so forth. So if we move both decimals along, do we have a 1-to-1? No. Do we have a 1-to-1 here? But now we're sitting in the tenths column. Do we have a 1-to-1? Yes, 2 remaining. Now again, this is just something created. But now we're moving it over, we're dealing with the hundredths. Do we have a 1-to-1? Yes, it goes in twice, there's 4 remaining. Move it over, do we have a 1-to-1? Yes, we do. 5, 0 remaining, 0.125. So that's just a little experiment. Instead of just saying, okay, we just move the decimal over. It's sort of like, well, what if we have a system where we move both over? So it's just a little thought experiment, just have a little conversation on creating decimals, but this is how we create decimals with division. And that'll be it for fractions. And I have a bunch of files loaded for you, some exercises and things like that. So look in your cams, and we'll take it from there.